All right, so we're given a number of molecules, 6.53 times 10 to the 28 of oxygen, and it says it occupies 15 liters. And so what volume would be occupied by 66.5 grams of carbon dioxide under the same conditions? Okay, so I guess one way we would want to start with is how can we use PV equals nRT? That's what we want to figure out. So in order to do that, we're going to need moles, and you can see that we've got moles here. Even though it's molecules, we can change that to moles, and then you can find the moles here. So we're going to change to moles. So let's find, first, let's find moles of carbon dioxide. So let's take 66.5 grams CO2 times 1 mole CO2 over 44.01 grams CO2. And this gives us 1.51 moles CO2. And then we want to take the 6.53 times 10 to the 28 molecules of O2, and we want to change it to moles. So we're going to use Avogadro's number for that. And moles of O2 is 1.08 times 10 to the 5th moles of O2. Okay, so what we want to do is try to figure out how to use PV equals nRT. Well, let's say that we have two gases like we do. Is there some way to set those two gases equal to each other? And the answer is yes. PV over NT equals R. For any gas, PV over NT equals R. R is a constant, so it's not going to change, even though these other things will change. But they will always work out to equal R. So what this means is the pressure of O2 times the volume of O2 divided by the moles of O2 and by the temperature of O2, that's going to equal R, but that's also going to equal the pressure of CO2 times the volume of CO2 over the moles of CO2 and the temperature of CO2. Okay, so do we know all of these things, and what is it that we're trying to solve for? Well, it says up here, we'll highlight this, what is the volume occupied by carbon dioxide? That's what we were really looking for. So this is our unknown. That's what we really are ultimately solving for. Okay, do we know enough of these things? In other words, we can only have one unknown. So do we know all these other things, the pressures, the temperatures, and the moles, so that we could solve for the volume of CO2? Well, let's see. First of all, one thing that's real nice is it says same conditions. What that means is that the pressure of O2 equals the pressure of CO2. So guess what? Those cancel out. And then it says that the same conditions, so that means temperature of O2 equals the temperature of CO2. So those cancel out. So now things have gotten fairly simplified. The volume of CO2, what's left? Well, we've got the volume of O2 times we're going to move the moles of CO2 up here, moles CO2, divided by the moles of O2. Now, do we know all of this? And the answer is yes, we do. We know the moles of CO2, we know the moles of O2, and we know the volume of O2. Obviously, the volume is changing in this case because that's what we're looking for. So this is going to equal 15.00 liters times 1.51 moles CO2 divided by the moles of O2, which is 1.08 times 10 to the fifth moles O2. And this equals 2.10 times 10 to the minus fourth liters, and that is of CO2. Again, we want to use PV equals nRT, and so this is a problem with an example like that.